This conference will now be recorded.
Okay, hi everyone. Today's meeting with Mr. Alin. He gonna speak about the quick important geometrical optimization for use large assemblies. So he got like many key stick notes for his topic. He's gonna show up like uh, more information about how to deal with how to optimize your large assembly. Our presenter is gonna be Alin. He's a certified Solidworks expert, and he also application engineer at Trimac, Javelin Trimac. And uh, hi, Alin.
Hi, Mohammed. Thanks for
Thank you
inviting
for.
me.
Yeah, you're welcome. I appreciate it.
So if you make me the presenter, I can share the screen.
Okay, hold me 1 second. Yeah, you are presenter now. Go ahead.
Excellent. Let's make sure I'm sharing the correct screen. So let's get starting. First of all, again, I want to thank you very much for inviting me to present at your user group meeting. It's a pleasure to be here. And because there are not that many of us here, I suggest if you have any questions at any time, do not hesitate to unmute yourself and ask the questions right away. So a couple of things about me for those of you who have not had the chance to meet me. I am working for Trimac Solutions. That's a SolidWorks reseller in North America, covering United States and Canada. I am based in Canada myself, very close to Toronto, at the half point between Toronto and Niagara Falls. From what qualifies me to deliver this type of presentation is the fact that I have been doing research related to large assemblies for a long time, working with my clients, helping them to become faster, and also learning from all their challenges. Based on whatever I learned, I had the opportunity to actually write a couple of courses, like the Large Assembly and Drawing Workshop, which seems to be extremely successful. A lot of people who are attending are writing to me after that to tell me that now they can work anywhere between 5 to 10 times faster than before. So that's pretty much what I'm going to use. Some of the information that I have in that course is going to be used in this presentation. Other than that, I love being part of the SolidWorks community. I've been delivered presentations to many user groups in Canada and United States, and now I'm so happy to come to Sudan. Other than that, yeah, I can continue bragging, but I guess that's enough. Too much bragging, it doesn't do any good. So let's move on directly to what we need. By the way, this is the area that we are covering in North America. So you can see Canada right here at the top, and then the southeast part of United States. Now, what is good for our clients is that they get access to technical support for a long time during the day. So imagine somebody who's here or somebody who's here in the morning. There is somebody who's on the East Coast, let's say in Halifax, Canada. So maybe 2 hours earlier than normal, and at night there is somebody in Vancouver again, very, very late. So we are really doing a pretty good job for our clients. Now, if this would have been the actual training course that I'm usually delivering, when we talk about imported geometry, we have to really go in details and cover a lot of stuff, like Why do you need to import something like a step file or an IGES file or a Parasolid file? What do you do with that file after you import? You use it in your assemblies because you download it from a website, or it's coming from your supplier, or it's coming from your colleagues from another department. A good example would be electronic PCB boards that might come from your colleagues in the electrical department. And then the question is, do you simply use it the way it is, or do you need to modify it? Or what happens if they do a revision, if the supplier does a revision to the original file and they send you a new step file? What do you do then, right? So pretty interesting questions. Then, as you probably know, there are more than one ways to import a neutral file in SolidWorks. And I'm going to use the word step going forward, but you can replace step with IGES, with Parasolid, with Inventor, with CATIA, with NX, with ProEngineer or Creo. So any type of imported geometry. So if I want to import a step file in SolidWorks, as you probably know, right off the bat, right from on the default, there are two ways to do that with 3D interconnect on or off. So again, based on your choices, you're going to have all kind of other options to use the file. Then the question is, how can I make sure that the whole loading process, the conversion process from the step to SolidWorks takes the least amount of time, right? How can you ensure that? Next, how many times have you guys imported step files with lots of errors? Like you almost cannot use the file sometime if you are really unlucky. So what do you do in a situation like that? Then, as I mentioned, what happens if the supplier, the person who sent you the step file, changes the geometry and sends you a new one? What do? Do you pretty much throw away all your work and import the new one and work around it? Or can you reuse it? And then again, when you get these revisions, how do you know what has changed? Especially if it's a big step file, maybe they did a small change somewhere. And if they didn't communicate this very well, you need to find the change yourself. And in the end, usually this imported geometry is pretty complex and is slowing down our performance when we insert it in assemblies or in when we create drawings, including that part. So we need to optimize the geometry. Now, this ideal agenda would take us a couple of days to go through. So that's why we're gonna have a different agenda for today. So the 30 minutes to 1 hour agenda, which is going to focus only on the last step, the import geometry optimization. Okay, and I'm going to use case studies. I'm going to use mostly SolidWorks for that. Now, when you deal with imported geometry, usually there are two complaints from users. Either the file, the assembly file where I'm imported or where I'm using imported geometry takes a long time to open, or after I open the assembly, I click on something and I wait. I add a mate and I wait. I change a window from the assembly to a part and back, and I wait 20 seconds, a minute or more. So this is even worse, right? These are usually the two complaints that we hear. The causes for these complaints can be quite extensive. So I put here a little chart showing the main factors. And surprisingly, number one on this list is the number of colors or appearances applied to faces in that imported geometry part. I'm going to demonstrate how bad that is. It can increase the open time a lot. Then obviously topological errors, if you have imported geometry errors. The other thing is, if you try to modify the imported file using features like delete face, or move body, just be aware that it will increase the file size. What SolidWorks does when you run delete face, it's still keeping the original geometry in the file, like the step file is the original model. And in order to modify it, it makes a copy of the geometry. And then it starts doing all the changes like delete face, move face, things like that. So that's why we recommend, if you need to use these features, after you finish that, save your file again out to Parasolid or to Step and import it back in SolidWorks to get rid of this, to stay with one one set of body data. Number of bodies, if you have a multi-body part, especially if you have surface bodies, that would slow it down, and the number of graphic triangles. So that will be about the geometry complexity, lots of fillets, lots of complex surfaces. So let's take a look at a few case studies. In this example, there is an assembly that takes about 11 minutes to load. And you can see it's a pretty small assembly. It has about 20 parts. What is specific about this assembly? It has colors that have been applied to individual faces. So you see this orange here. Instead of applying the orange color to the whole part, when the file was imported from the step file, Solidworks apply colors to each face. Like this is orange, 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 and so on and so forth. And inside there are other parts that have 80,000 faces, each of them with their own color. That slows you down on the open time, and also it adds a lot of lag. You can see here on the right, the same assembly. I clean up this face level appearances, and I decrease the open time by a factor of 5. And let's go to SolidWorks. I'm going to show you an example. By the way, I'm going to use SolidWorks 2022 Service Pack 0. So we might have a few surprises. This is the first time I'm doing a presentation with this version of SolidWorks. Let's hope we're not going to identify anything bad. What you see here is one of the parts that made that cab. I took the liberty to open this assembly ahead of time before our meeting, just because I didn't want you guys to wait the amount of time that I required to load this. So if I go to the performance evaluation of this assembly, you can find out that one file took 230 seconds to load, right? So that's almost 4 minutes. The other one took 6 seconds, and the other one took less than 3 seconds. So that is spectacular. Now, there is no difference in geometry between this one and this one. They are the same geometry. The difference is the number of appearances that are in this part. So how do you find this large number of appearances? You're going to use, again, performance evaluation inside the assembly. And if you scroll down a bit, if you have any document that has more than 100 appearances applied to faces, it's going to be listed here. So if I go show these files, it tells me there is one file with 14,000 appearances. Okay, so that is pretty nasty. Anytime you have more than 1,000 appearances, you should consider cleaning them up. Now, how do you clean them up? That's a pretty good question. I'm not going to do it with these files because it's going to take a bit longer. I have another file that it's a little bit easier to work with. Is this part? Just waiting for you to see my screen. Okay, so this is a Parker valve. It has 63 bodies. Right now, there is no indication from inside the part file about how many appearances are inside the part. Let me see if I can move this bar somewhere else. No. Oh, let's move it here maybe. Okay. So how do you find out again the number of appearances? You simply insert this part into a dummy assembly, any test assembly you want, and then again you run performance evaluation, and you can see here it tells me that this part has 11,000 appearances, which is crazy, right? How do you get rid of the appearances? So you notice here is the display manager. If I'm going by color, you can see there are various appearances, but if I sort this hierarchy by hierarchy, it's going to show me all the appearances applied to faces. And if I expand this, you can see I have faces from 1 to thousands of faces that get this color applied to. Let me close this assembly and go back to the part. Now let's clean up this part, okay? So allow me to save this as a copy. So I'm going to save it as a copy. I'm going to call it PM1 appearance. So I'm going to get rid of all the appearances. I'm going to leave only maybe the gray color. So I'm saving a brand new part. And SolidWorks is going to open that new part. Okay. And let's look at two ways to get rid of these appearances. One way you can do it is right-clicking on the top name in the feature manager, go to the drop-down next to the appearance button and use the option remove all part appearances. Just be aware that this can be time-consuming. It can take minutes for that to happen when you have 11,000 appearances. A faster way to do that is going to the configuration manager, so this space, right-clicking anywhere in this area and use the option to remove all display states. So as long as you don't care about the display states that are inside this part, I can press this button. And the result of removing all the display states, you will also lose appearances. Okay, so let's try this and see what happens. I'm going to say yes. And you can see the circle spinning. SolidWorks is trying to get rid of the display state and all the appearances. And it took just a second for this to turn into a grayed out part. Okay, so let me save it. One thing I can do, I can put this together with the other part inside an assembly. I think I still have, no, I don't have that assembly. So let's insert this again inside an assembly. Let's make an assembly from these two parts. Just gonna, I hope you guys know you can pin this dialog down. So I can say, okay, I want this part, and then I want this part. So I can insert the same part, actually I can insert multiple parts one after the other. Okay, and let me save this assembly. Let's call it, sorry, where am I? I'm gonna call it comparison. So we're gonna compare the opening time for these two parts. And now I'm gonna close SolidWorks and I'm gonna open it again. Okay, so let me make sure that SolidWorks, it's out of my memory before I open it again. Just because I had that big part before, you can see SolidWorks was still closing. Okay, I'm gonna open SolidWorks 2022. And I'm gonna open that comparison assembly. Okay, file open. It's gonna open resolve. That's the default that I have on my computer. And we're gonna find out how long it takes to open one part versus the other. It's pretty fast in this case. But if I go to performance evaluation, you can see that the first part took 2 seconds to load, while the second part took less than a second. So it's twice as fast for something that took me also very little time to remove that extra geometry. What else can you do to improve performance? So that's the first thing I want you guys to be aware of. Just simply go to the performance evaluation. If you see appearances listed there, you have to think, okay, is this gonna slow me down or not? The second thing is, how can I reduce the number of bodies? Because many times that when you import a file, you get much more than what you need, right? So what exactly do you need when you use a supplier part in your assembly? So for example, for this part, let me open it on its own window again. Let me save it with another name. I'm going to save a copy. And let's call it PM optimized. Okay, so this new part, notice here I have 633 bodies. Each body that I have in this part is pretty much created by one of the imported geometry features that I have in there. So if I can find a way to get rid of all the imported geometry features that are irrelevant for me, I'm also going to reduce the number of bodies. The main problem is, how can you select the ones that you want to get rid of? There are all kind of things here on the inside that you can see, all kind of bodies here that I would like to select and eliminate. So the question is, how do I do that? And a first tip, I hope you guys know, but if you don't know, when you are in an assembly or a multi-body part, if you want to hide something, it's enough just to move your mouse over that specific component if you are in an assembly, or specific body if you are in a multi-body part, and press the tab key. Okay, so if I press tab and my mouse is over that, a face that belongs to that body is going to be hidden, right? So if I move my mouse over here and I press tab, notice how that body disappeared. Let's press tab here too, tab and tab, right? You want to bring that back, you simply move your mouse again over that area and press shift tab. Okay, so that's what you do. So if I move my mouse over here and I hold down shift and I press tab, I'm getting back the previous part. The thing is, if you deleted multiple, or not deleted, hid, if you already have hidden lots of bodies and you're wondering, okay, where are they? I don't know where they are to move my mouse over. You can also press Control and Shift and Tab. So 3 keys at the same time, Control, Shift, and Tab, and it will reveal all the bodies that are hidden, or if you are in an assembly, all the components that are hidden. And then with your mouse, you can select the ones that you like to become visible. Let's say I want this guy and I want this one. Okay, and then if I release my keys, Control, Shift, and Tab, guess what? The other one is gonna it's also gonna disappear. If I do a rebuild, you can see that it's gonna stay hidden. Okay. If you have lots of bodies that are hidden, let's say I hid a ton of them, this one and this one and this one, and now I would like to make everything visible. One thing I can do, I can hold down Control, Shift, and Tab to see a preview of all the hidden bodies. And as long as I hold these 3 keys down, I can right click on the screen and use the option Show. So it's going to show everything that is hidden right now. Okay, so there you go, I'm back in business. So the problem is I don't know exactly what I want to hide. There are too many of them that I want to hide. It's much easier for me to select what I want to keep. And unfortunately, there is no way to select features directly from the graphic area. Like if I click here, let's say I'm clicking on this face, you might say, okay, you probably selected all features because I can see it in the feature manager being highlighted. But actually what you selected, it's a face. So that's not gonna help me. So what I'm gonna share with you in the next few moments is how to use appearances. So appearances were our enemy a moment ago, now they're gonna be our friends. How to use appearances to create selection sets. Okay, so in this case, I'm gonna select the face that belongs to this body or to this feature, and I'm gonna apply an appearance at the feature level. You can see here that you have 4 different levels. You have face, you have feature, you have body, and you have part. I'm gonna select the feature. And you can see in the property manager that whatever color I'm gonna apply, let's say I'm gonna apply orange, I'm gonna apply at the feature level. So all the faces that belong to these features are gonna be orange. And I can select a few other faces in order to color their features, like this one, probably this little tab here I would like to keep, and all the wires. Okay, so allow me to select also the wires that I want to keep. So this one, this one, this one, this one. Let's spin this the other way around. I want to keep this and this. It's pretty much marking or tagging or coloring the entities that you'd like to keep. So let's zoom to fit. Is there anything on this side? No, I think I selected everything I wanted to keep. Okay, I'm gonna click OK. So let me split the feature manager because I want you to see this. I have the features in here, Some of them got the orange color. You can see a few of them got the orange color. But if I go now to the display manager, notice the orange color. This one has been applied to various features. When I select it, I actually select the features. So this is a nice way to create selection sets based on color. And now I can simply say, you know what? Let's invert this selection. Okay. So actually, before I invert the selection, let's do something. Let's invert the selection. So you can see now all the other parts or all the other features that I do not need. I mean, there are 3 things that I need or 4 things that I need, which are the front plane, top plane, right plane in the origin, right? But the rest I do not need. So let me press the delete button on my keyboard or right click on the screen and use delete or suppress. You pick whichever you want. So in this case, let's say we're gonna delete it, okay? So I'm gonna press delete. Now it tells me I cannot really delete everything. We know we cannot delete the front plane, we cannot delete the top plane or the origin. I'm gonna say, okay, I know that. Let's say delete everything else. So from 63 bodies, I'm down to 16, okay? And if I don't really need this color at the end, I can simply remove the appearance. So let's do one more thing. I'm gonna save this part in its own window, and I'm gonna insert it in that comparison assembly. Let's see if we can spot the differences. So I'm gonna insert that optimized part in here. And looks pretty much the same as the other one, right? I just got rid of what was inside. I couldn't care less about what was inside. So let me save this assembly and let's close SolidWorks again. Actually, let's close all the files. We're gonna close SolidWorks and let's reopen it again. The reason I'm closing SolidWorks, I wanted to make sure I don't have anything left in the cache. So we're not gonna cheat here by opening things fast because they are already in the memory. Let's see what's going on. I'm going to open again this comparison assembly. By the way, I know that you guys are asking questions in the chat. I'm not going to focus on the chat right now. Mohammed, if there is any interesting question, please interrupt me, and I'll be more than happy to answer it as we. Oh, sorry, I opened the wrong one. I'll be more than happy to answer as we go. You see, I opened that big board panel. Let me crash SolidWorks. We're not going to wait for that. It takes about 5 minutes to load, so we're not going to wait for that. Just curious, how is the screen? Can you guys see okay? Is there any lag? Is my voice coming through acceptable? Yes, maybe. So I'm going to open this comparison assembly. And let's take a look at the performance. Okay, so it's open. I'm going to go to performance evaluation. And you can see that we actually improved significantly on the open time. We went from 2.3 seconds to less than a second once we got rid of the colors. And then again to a quarter of this, like 75% increase in performance by removing the bodies that we don't need. So a pretty nice return of investment, right? You work for a couple of minutes, but then if you use this over and over and over in your company, you're gonna save time. Let's take a look at the third case study. What if you deal with an assembly that comes from a step file? So I'm gonna show you different techniques for working with an assembly like this. I'm gonna open up another example. Is gonna be this assembly. It has 425 components. And most likely I do not need all of them. So the question is, how can I keep only what I need? Okay, so I'm going to show you different tools that can achieve in the end the same goal, and you can combine them, right? So the first thing I'm going to say, let's take a look at the performance evaluation and number of components. So I was right, 425 parts. I don't know if you have the opportunity to work with selection tools. So these are great for saving time. Like if I quickly want to select everything that's internal to this assembly, so parts that I cannot see that are completely enclosed, I can use select internal components. Pressing that button is going to go and find what doesn't have any contact to the outside world. Let me isolate them so you guys can see them. You can see all these parts. I don't care. I just need a valve to put in my assembly. I don't care what's inside the valve. Okay, so allow me to suppress them. Okay, so let's see. We started with 425. Now I have 241 components. So it's a pretty nice improvement, right? Pretty much a pretty nice simplification. What about very small components, things that are super small? Well, again, here you have an option to select by size. So let's start with 1%. So 1%, there is nothing smaller than 1% of the volume of the assembly. What about 2%? Looks like there are 4 components that get selected. Okay, let's see 3%. You can see 74 get selected. 4%, 126. 5%, 150. 6%, 158, but now I'm getting some of the big parts that I don't want to get rid of. So now let's go back to 5%. That's what I want. Okay, click OK. Let's do a quick isolate to see which components we selected. And you can see there are all kind of plugs and nuts and washers. I'm gonna say, let's say we don't need them. Okay, so I'm gonna suppress them. If there is any one that you think you should need, maybe a certain plug or something like that, just make sure that you do not suppress. Let's go exit isolate and take a look again at the performance evaluation. So what do I have? I have only 91 components. So we start with 425 and we got rid of more than 3/4 of the components, just like that. Now, that's one way to do it using advanced selections, okay? But there are a few other things you can do. Remember the appearances technique that I show you for parts? They can work also inside assemblies. So let me bring back, let's presume we didn't do the work with the advanced selections, okay? So let me bring back everything that has been suppressed. So again, a nice shortcut to select everything that's suppressed right from there and allow me to unsuppress them. So we are back to how the assembly looked like when we opened it. And we're gonna use again a color to define a selection set. Let's use again orange, for example. Okay, so waiting for the resolving of the suppressed components to happen. And let's pick up any of these components. This time, when I apply the color, I'm going to apply it to the component level, right? Not feature, no body, no part, but the component level. So that is going to be orange. Okay, what else do I want to keep? I want to keep this and 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 this. You can also do selections with a box, right? Like all of them in this box. I want to be orange. I want this guy, this guy, this guy. All these big parts I want to keep. So I'm going to make them orange. I also want these tie rods. okay? And on this other side, I want these big parts. You probably notice that as I'm selecting, the selection start lagging more and more and more behind my selection. So if that happens to you, if you need to apply appearances to, let's say, hundreds of parts, you can stop at this point, just click OK. And the other thing you can do, you can select one of the faces that has been already colored and use the option Copy Appearance. And then select a new part that you want to apply the appearance to, a new component, and use the option Paste Appearance. Okay, so I can paste it at the assembly level. Even better, when you run the Paste Appearance command, you can actually use this pin to keep this toolbar on the screen. Okay, so it's going to stay there. Unfortunately, by default, defaults to faces, so it applied an appearance to a face, which I didn't want to do, right? So allow me to remove that appearance from that face. And I'm going to say from now on, everything I want to apply an appearance to is going to be at the component level. So I'm going to click on this and paste. Click on this and paste. Okay. The other thing you can do, you can also go to the keyboard shortcut, so customize and keyboard, and look for the paste appearance command. And you can apply a shortcut. In my case, it's Alt P. So let's see if that works. I'm going to click on this face, Alt P, click Alt P, click Alt P. So you can see how just by selecting faces and using your shortcut, you are your selections. So Alt P and Alt P. And I think I have one more set, Alt P and Alt P. And then I'm done with copying appearances. And all this work was done just because now I have an appearance that looks for parts, for components. So I can click on this, and what I have selected are those components. So now I'm simply going to say invert selection. Right? So I want the opposite of what I selected to be selected, and then delete or suppress those components. So let's see, we started with 425 components, and now we have just 57. I'm going to say that's a pretty nice decrease in complexity. So appearances can be your friends. Any questions so far? No? Okay, let me reload this file because I have another great tool that I would like to share with you. So we talked about simplifications using appearances. Let's talk a little bit about simplifications using the Defeature tool. It's one of the most powerful tools in SolidWorks. Starting with SolidWorks 2019, it became even more powerful. And in 2021, became excellent. So I'm going to show you a little bit about that. Okay, so pretty much I'm asking SolidWorks to reload this file. And you can see I'm back in business with the 425 components, 425 parts. So the Defeature tool can be found under Tools menu. And right here is the Defeature. It has two flavors. The one on the left, option number 1, is Simplified Geometry, which I'm going to demonstrate in the next case study. The one on the right is called Silhouette. So I'm going to use this one. Let's go to the next page. So what SolidWorks allows me to do now is to select multiple components and then apply a certain type of simplification. Like one thing I can say is, I would like this guy, this guy, this one, this one, this one, this one, this one, this one, and this one to be simplified to the smallest rectangular, parallelepipedic box, I can put them in. So you can see here the option for the simplification method as a bounding box. So let me hit add group. And now on the right side, SolidWorks is going to give me a preview of the end result that we're going to achieve. So let's see what happens. Pretty much it's every component that I selected is going to be placed in the smallest possible box that that component can fit in. So I'm simply turning them in very simple geometry but still I know what space they occupy, so I can do the space claim. Okay, and then I'm gonna say I want these tie rods to be turned into cylinders, so it's gonna get rid of this chamfers. Okay, so you can see them on the right. What else can we do? Let's select these things here, and let's turn them also into cylinders. All right, so you can see the result. Now, no, you probably notice there is a little bit of a graphic glitch here. So let's see if I can turn them on and off. That's a bug, but you can use this option, highlight process bodies, to color the ones that you already modified and then turn that back to get the colors back. Okay, let's try something more interesting. These parts have actually holes in them. And let's imagine I wanted to preserve those holes. Those holes are all the way through. Okay, so for them, I'm going to use a different type of simplification method. I'm going to use the option tight fit outline. It's like whatever footprint they have as I'm looking from a certain direction. Imagine almost like a convert entities, getting the silhouette of that component that gets extruded with the biggest thickness of each component. And one of the options that I have here is the ability to keep the internal loops, meaning every hole that's all the way through can be kept. Okay, so I'm going to use the option keep internal. Let's define the direction of extruding this. Let's say it's going to be based on one of the planes. Let's see which one makes sense here. Or you can select one of the faces, right? So notice here I have these planes, not this one, not this one, this one. That's the direction I want. And let's add this as another group. Takes a bit longer than the bounding box because now it had to find pretty much create sketches that are based on the contour. Right, so you can see those holes. So this one, for example, has a hole, the hole is there, and also the mounting holes. For these three, let's turn them into cylinders. Okay, and for on this side, I'm gonna do only one of them. Let's say these two, I would like to also do a projection, like a tight fit outline. That's the option that I'm gonna use. And for the direction of my projection, SolidWorks can guess that, but I want to be always in control. Let's say perpendicular to this face. Okay, so add a group and you're going to see the result here. Of course, I could have selected all the other ones, but I don't want to waste your time because, as you can see, it takes a few seconds for that to be computed. Pretty nice result. What do you guys think? Right? Now let's do one more, a crazy one. We're going to take this part, and this time we're going to do a projection from the top, a projection from the side, and a projection from the front. Do extrusions, right? Like 3 separate bodies. And we're going to find the space that is common to those 3 bodies. So that option is tight fit outline with multiple directions. So it's 3 directions. And let's establish one of them. It's going to be again perpendicular to this face. So I'm going to go add group. And we're going to see the result. Takes a bit longer, right? Because it's a much more complex operation, but it's pretty impressive. It's doing a pretty great job, right? And I could have done it with all of them. Now, what is really interesting, if you have SolidWorks 2020 or 2019 or older versions, the only option you have is to save it as a new part. So all this is going to turn into its own part. If you have SolidWorks 2021 or 2022, you have this option to create a new configuration inside the assembly. So I can create here a new configuration. I can even include the top plane, right plane, and so on and so forth. And now I still have one file. Maybe I need it fully detailed or a detailed drawing, but if I use it in another assembly, I want it to be as simple as possible. So once this is completed, let's take a look at the end result. So notice here I have two configurations. I have the featured configuration, which is this one, and I have the full configuration, which is the original, right? Now, what do I gain from this? So let me insert this into a dummy assembly. I'm going to insert it twice, right? So one, I forgot to select it, I think. Okay, insert component, yeah, this guy. Okay, and let's make a copy of it. Oh, sorry, it's a sub-assembly, my bad. So let me make a copy of it. Oh, it doesn't want to do it. I'm gonna. Oh, I think GoToMeeting is slowing me down a bit, so I'm gonna insert it a second time. There you go. And the second one, I'm gonna turn to the feature configuration, right? So I'm not gonna measure the open time because we know it's the same part. But one thing that I can check is the number of graphic triangles from one to the other. Of course, in this case, I'm cheating a little bit because I don't have all the copies of these ones, but the number is gonna be, the difference is gonna be huge. So let me use the option nested for the assembly visualization. By the way, if you want to learn more about the assembly visualization, I have a presentation that's going to be delivered at 3D Experience World that I'm covering this in detail. Let me use graphic triangles as the number that I'm going to look for. So you can see from 2.6 million to 10,000 graphic triangles. Big difference, right? So it's going to make a huge difference in performance once we work with that. The other thing that's interesting is that the mass of this configuration has been preserved from the main configuration. So center of gravities and everything else is still going to be based on this one. So pretty cool. Now I just wanted, let me just take a look at the time. I'm a little bit over the limit that you guys agreed. So Mohammed, let me know if I can show you a few other things, or we need to terminate this presentation. So I cannot hear you. So can we go for another 10 minutes or so, or that's pretty much it? Unless there's something wrong with my speakers. Yeah, Mohammed, maybe write in the chat. Can we go for another 10 minutes, or we are done? Oh, you already wrote in the chat. Sorry. Yes, feel free. Perfect. Okay. So I'm going to show you one thing, how this simplification happens when you go from 3 different directions. So I have this part, and what I'm going to try to do is manually create a simplified version of it. Okay. Let's start by picking up this face, create a sketch there, and I'm going to project this whole body on this face. So instead of using convert entities, I'm going to use silhouette entities. So what you do, you take the whole body, press OK, and Solidworks is going to find its projection on that plane. Okay, that's one thing. Now, number 2, let's create a plane that's gonna be at the middle of these two faces that I selected. And on this plane, I'm gonna create a sketch, okay? Now, what I want on this sketch is again the projection of the whole body. So silhouette entities, select the body and click OK. As you can see, I'm getting the whole body projected on the plane. It's not intersection curve, it's not convert entities. Let me hide this plane. I don't need to see it. I'm going to create another plane that's going to be in the middle of these two faces. Right, so mid plane, right? Mid plane. And on this plane, I'm going to create a third sketch. On this sketch, I'm going to run one more time silhouette entities. I'm going to pick up this body. And now what I'm going to do with these three sketches, I'm going to extrude them. Okay, so let's take sketch number 1. And I'm going to extrude. How much should we go? Let's go in the opposite direction. I'm going to go through all. Okay, so as big as this part is. Do not merge the result. I'm going to keep it as a separate body. Okay, and let me hide this new body that I created. Let's start with the next sketch. So this sketch, extrude. How much do we go? Through all in direction 1, through all in direction 2. Do not merge the result. Click OK. Right? Let's hide this body. And last one is this sketch, which I'm going to try to extrude. And at this point, I'm not getting a good preview. So it's something wrong with this sketch. Let's take a look at the sketch itself. I'm going to hide also this body. Let's edit the sketch. And the first thing you're going to see is that even though I have shaded sketch contours selected, it doesn't shade the contour inside. So that means there is a disconnect between two ends, right? How do you find that disconnect? What do you guys do usually when something like that happens? Just curious. I'm just reading in the chat, or feel free to unmute yourself. No? So what you do, you'll go to the tools menu, and then there is a set of tools that is designed for sketches, sketch tools. Here you're going to find a tool called check sketch for feature. Like, can I use this sketch in a base extrude? Let's check. Tells me no, but I can help you. And you can see right here, it found a disconnect between a line and an arc. So I'm going to say, excellent, thank you very much. Let's take a look what's going on here. Okay, cool. So I'm going to cheat a little bit here. I'm going to delete this on edge relation, and I'm simply going to attach this guy to this guy. Notice I'm getting my contour, right? Let's show again this body. And let's extrude this sketch through all in both directions without merging the result. And I'm going to hide now the original. I'm going to show the other two. So we have three bodies, right? We got the printout of the part in 3 direction, extruded like that. I'm going to select those 3, and I'm going to run combine with the option to keep what is common between them, right? So let's click OK and see what happens, right? So notice this is the same result that the feature did for me. That's what actually happens on the inside. Just wanted to show you one more the feature silhouette. I don't think we're going to get into the feature simplify today, but maybe you're going to invite me to another session, or you're going to attend one of my presentations at 3D Experience World, or one of my training courses. Just going to show you one that I learned. Not I learned, I got it from a training course with a customer. They allow me to use this file. So when you deal with PCB boards, you can get a lot of complexity. Like this part, they have it like 20 times inside their machine, and it's slowing them down like crazy. Okay, so let's run the feature like we did it a moment ago. So feature, I'm going to use the option silhouette. Next. And let me pick up this part. Now, this part has two mounting holes. I would like to keep them, right? So what do? We use tight fit outline with internal loops. So I'm going to add this part. Okay, so let's confirm the holes are there. Great. This and this, the spacers can be cylinders, right? So let's make them cylinders, add them as a group. This one, there are 3 layers that I would like to add them together and as a bounding box, but I want also to merge them into one body. Okay, so these 3 will be merged as one body in my final part. Okay, great. Now let's deal with the parts that we have here. So I'm going to use bounding box for all this, the ones that are big enough to create possible interferences. I don't know if this should matter, but well, I can select them. Okay, add them as bounding boxes. Notice the processing, it's a little bit slow. That's because I didn't specify the direction that I want to choose for this type of simplification. And then Solidworks has to figure out what direction does Alin want. So it's probably a better idea to pre-select the direction that you want. Okay, so I just remind everybody, this is where you select the direction. So for example, for this part, I'm going to use the tight fit outline and I'm going to specify the direction. I want to go normal to this face. Okay. You can see the result. It's giving me this. Now, this guy and this guy, I want them to turn into one body. So I'm going to use the option to enclose them in one body and use the bounding box for that. Okay. So let's add a group. And then this one and this one also as one body, bounding box. Now I have to think, do I need any cables to go through here? Do I need to specify where parts are? Maybe I want this guy and this guy again to be a bounding box. And I'm going to do one more and I'm going to stop. It's going to be this one. Okay. Perfect. Let's go next. And let's create a new configuration. And let's see if there is any benefit to all this work. Okay. Again, you can see this configuration and I have the parent configuration. So like before, I'm going to insert this into a dummy assembly. Let's insert it twice, here and here. Okay. And I'm going to get one of them to be shown in full configuration. Okay, so you can see this and you can see that. So again, let's run the assembly visualization. Let's go nested. So we can look just at the top level components. And instead of the mass, let me go to total graphic triangles. So if I'm zooming in here, you can see I started with almost 500,000 triangles and now I have only 688. So it's a huge simplification. Now, some of the graphic artifacts that you see on the screen are due to Solidworks not liking very much GoToMeeting in my case. So if I wouldn't have GoToMeeting on, this would probably be okay. Okay, so there's one thing that I didn't cover, which was the feature simplify. I'm more than happy to do it in a future meeting, or if you attend one of my training courses or one of my presentations, I'll cover that too. That's great for preserving mates on assemblies, while still simplifying things. So if I'm going to ask you to remember 5 things. So like 5 takeaways. Appearances. Just always minimize face level appearances. Also, appearances can be friends. Remember, we use them as selection sets. Whenever you run delete face, move body on parts that have imported geometry, just make sure that will increase, just remember, they will increase your file size. Take advantage of advanced selections and try to learn how to use the defeature tool because it's amazing, okay? So those would be the main takeaways. And when I work with customers, that's pretty much what they tell me after the course. I call them a month after, and they say, yeah, we can be much faster than before. One of the things that you might want to tell your colleagues is that whenever they download the part from internet or they get it from one of their clients or suppliers, it's a great idea to invest 5 minutes, 10 minutes, 20 minutes in optimizing the geometry before saving that in your library and using it inside your assemblies. Those 20 minutes are gonna save you hours and hours of waiting, okay? And I'm just gonna leave this on the screen in case you guys would like to get more free training. As you can see, we are writing hundreds of articles, thousands of articles that are free to read. Just go there and let us know if you have any questions. So I'm just going through the chat to see if there is any questions. So I noticed, I think I noticed one from Mujahid. Is there any limitation to the number of size selection? So it goes 1% of the time from 1 to 100, right? So it's all about the volume if that's what you're talking about. So those are the only limitations. Other than that, yeah. So Mujahid, you knew the answer about the check sketch for feature. Perfect, excellent. So just want to say thank you very much for inviting me to your meeting. And if you have any other questions, I'm more than happy to answer them.
Thank you very much, Mr. Alin, for your presentation. It's very insightful and easy to understand. I will schedule your presentations with experience 2022. So my question is, sometimes we have imported geometry, the Solidworks treat it as surface, or I don't know the exact word, but treat it as just surfaces, as triangles. I don't know what the type of this part, but just appear as a surface, not a solid body. So how can I treat this type of parts?
So there are a couple of things you can do. One is actually using the feature. I don't know if you noticed. Let me share my screen again. So one thing that I use in one of the examples was actually a part that had errors on the import. So I think you can still see my screen. If you remember this valve assembly, if we're running the check tool, you're gonna find out that one of the parts actually has big errors. It came as a surface body. So the cool thing about the feature, it's still being able to put a box around it and turn it into a solid. So that's kind of the easiest way to deal with it, as long as you can have this type of simplification. Otherwise, you might require some manual fixing of this part, right? So if I'm looking at this, came as a imported surface, and I can see here all kind of issues. And you're right. If I go to the check tool and I run the check, it tells me, yeah, man, you have problems, right? So one problem for sure is here, but I think there are more than that. So probably one thing that I need to do is to run import diagnostics to find out all the issues that are there. And this is actually a pretty great tool for deleting things that you don't need. Like this face, I don't want it. I can actually delete it. So I'm going to delete the ones that are really bad. And then I'm going to use the same tool to fill the gaps, to turn it back into a solid. So that's one way to do it. One thing you can do, if you want to read more about that, I wrote quite a lot of articles on this. I'm going to put them on the chat in case you guys are curious. You can just Google my name, by the way. So first of all, I wrote a whole series of articles on working with imported geometry. So the ultimate guide to working with step files. If you have time to read it, go through it. Another good, actually, you know what? Allow me to send Mohammed an email containing the links for articles dealing with fixing imported geometry. So a good one is, let's see where that one is for imported, this one. I'm gonna put it in the chat. Okay, so this pretty much covers everything that, it's almost like a case study on how to run the import diagnostics and how to use it, not to just to find the problems, but to actually fix the problems. So read it, and if you have questions, don't hesitate to email me. Another question that I'm seeing in the chat is from Mauricio. So initially I wanted to attend the 3D Experience World in person, so I submitted 5 proposals for presentations. And once they got canceled, I was just told yesterday that I can submit them again as virtual. So I'm gonna have to record, I think I'm gonna do just 2 of them, one on assembly visualization and one on similar to what you saw today on imported geometry. Yeah, so I really hope I'm gonna be able to do it next week because they need the videos. So maybe I will present this this year too as on the virtual track. Okay. Any other questions? Anything else? Okay, so if there are no questions, I just want to say again, thank you, Mohammed, and thank you to all of you for accepting to go way over time. I think we went 20 minutes over time. Thank you very much.
I think Muhammad, his voice is not clear, but thank you very much for your presentation. And we hope.
Yeah, you hear me now?
Yeah.
Yeah.
You
hear me now? Yeah, thank you so much. Appreciate it.
Yeah, looks like there is a little problem with the audio,
If
but
anybody got a question?
oh, now I
feel free
can.
to reach out to me. Yeah.
Okay, perfect. So just one thing I want to
Okay,
say,
guys, thank you so much for.
You can also email Mohammed and he can get in touch with me and I can answer them via email, no problem.